looks back at you, because you're going to see some really interesting things. The connection between the variables and the constraint. This is where you start appreciating the beauty of the constraint programming implementations. Okay, let's get started. So what we're going to talk about is mostly variables. And what a variable does is essentially answering some queries from the outside. What is the minimum, maximum value? What is the size of its domain? It's also linking itself to constraints. And I don't want to tell you too much, it's going to come. And then obviously it can update its domain. So removing values from the domain, updating the min, the max, and so on. Now the variable to do these things is storing a variety of things. Obviously a link to the solver, because the variable will have to talk to the solver. You'll see that. It's also obviously encapsulating its domain. And then it has a link to the constraints, and that's what I want to talk about. All right, so remember this fixed point algorithm that we have seen. The core loop here is popping constraints from the queue, propagating them, and then pushing new constraints on the queue. And those constraints are those for which the domain of the variables have been updated. So when you propagate the constraints, you look at the variable whose domain have been modified, and then all the constraints floating around, right, the domain store. Those constraints whose domain have been modified have to be put inside the queue. And so what we're going to talk in this video is how we do this. These three lines that you see there. This is what we're really going to talk about in this video. All right, so the variable contains all the constraints it appears in. That's one of the fundamental things that it does. Now these constraints, they belong to different lists. So we are keeping track of these constraints in different lists. Why? Because they respond to different things. So some of the constraints are being propagated when you modify the min or the max. Some of the constraints are propagated as soon as you remove a variable. And other constraints, like the not equal constraints, are only propagated when a variable is assigned, gets bound. Okay, so essentially what the variable is doing is keeping track of all the constraints it appears in, but it's classified these constraints in different lists such that it can wake these constraints, unqueue these constraints, wake them up, unqueue them in the propagation queue appropriately based on what is happening to its domain. And that's one of the key aspects of the implementation of a constraint programming system. All right, so this is the interface at a high level of an integer variable. I'll add some component in the last slide, but this should be good. This should be good for now. So what you see at the top are the accessor. Then you see the domain updates, and this is the link between the variables and the constraints. So this is used to say, hey, variable, you appear in these constraints, and these constraints must be changed, must be propagated, must be unqueued when the domain is changing. Hey, variable, you appear in constraint C, and you need to propagate this constraint when you become bound. And hey, constraints, you appear on constraint C, and you have to be, propagated as soon as your bounds are changing. That's what these methods are going to be. They're going to tell the variable, hey, you appear in this constraint, please keep track of this. All right, so let's go to these three components of a variable one step at a time. The queries, the updates, and the links between the variables and the constraints. All right, so the first thing that you have to see is what the variable itself contains. And so you see the solver there, very important, you'll see why. Then the domain, obviously a variable has to have a domain. And then these three lists. The list which has to be propagated as soon as the domain is changing, the list that has to be of constraints that have to be propagated as soon as the variable is bound, assigned, and the list that needs to be propagated as soon as the min or the max of the variable is changed. Now, these are stacks of constraints. They keep track of all the constraints which are linked to the variable. Now, these are state stacks, which means that we have to restore the size of these stacks in the same way as we were doing that for the sparse set, because you can actually add and remove constraints during the search. All right, but let's ignore that for a moment. We'll talk about this later on. All right, so this is the implementation of the constructor. You get the solver there, the min and the max values. This is the domain. The domain is between min and max. And you basically store the solver, create a sparse domain, and then create three lists, three stacks of constraints. This is where you can accumulate the constraints that the variable is appearing into. And when we see the constraints implementation, you'll see, how we add that to the variables. Now, this is part of the state, as I've told you. So this is a state stack. We'll have to, I'll tell you later on a little bit how this state stack is implemented, but it's very much the same thing as the sparset. All right, so this is the accessor. They are amazingly boring. The only thing that they do is essentially delegating to the domain. So nothing fancy here. If I want to know the min, I'll ask the domain, what is your min? If I want to know the size, I ask the domain, what is your size? So nothing fancy here. More interesting are the constraints link, right? So this is a method that you call when you want to link a particular variable, the variable that we are implementing here, and a constraint C. And that constraint has to be propagated when the domain is changing. And the only thing that you're doing here is taking these constraints and putting into the stack that corresponds to the on-demand events. So this is all the constraints there that have to be propagated as soon as the domain is changing. And this is the same thing, but for the two different events, when the variable is bound or when the bounds of the variable, the min and max of the variables are changing. So you're just linking these two things, right? So you receive this constraint that you appear in, you put them on a stack, and now that you know that if you are being modified, if the variable gets modified, the variable will have to, wake up these constraints and propagate them. All right? All right, good. So we're adding essentially constraints to the list of constraints that the variable appears in. But we also link them to specific events of when they need to be propagated. All right, so now how do we do the updates? The updates are very, 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 very natural, right? So we're going to, if we want to remove a value from a variable, we are going to remove the value from the domain of the variable. Essentially the same thing for everything. Now we are passing a domain listener here. And one of the very important things I have to tell you is what this domain listener is doing. This is really critical, okay? What is this domain listener doing? Can you guess? Of course you can, right? So this is my domain listener. And what is basically is response to the elements of bind, change, change min, change max. And what it does, okay, so let's assume that, let's say the domain has been changing. Okay, so this method here is going to be called. And what's going to happen is that we're going to call the method schedule all and on domain. So what this does is going here, right? So we get a stack of constraints, and we're going to go over all these constraints on the stack, and we're going to tell the CP solver, right, the solvers that we have, hey, please schedule these constraints to be propagated. You see how cool this is, right? So when we do a remove value like this, okay, so we pass this listener to this remove value. If that listener actually call the method change, the variable will say, aha, my domain is changing. I have to wake up all the constraints in this particular stack of constraints. And the way the variable does this is by going through the list of these constraints and telling the constraint solver, please, please propagate these constraints. And what the CP solver is going to do is add them to the list of constraints, and they will be propagated at some point. Now, the other methods that you see there, bind or change min and change max, they do exactly the same, but for different events and different lists, obviously. So when the min is changing, what the listener is going to do is waking up all the constraints which are on the on-bounds stack. And once again, it's going to tell the solver, hey, propagate this constraint. So you see what is really nice here, right? So what we do here is that we are basically calling, okay, let's go and see this. So we remove the variable there. We call the domain of the variable to remove that value using the listener that I've shown you, right? Boom, 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 this listener. Now, what is happening is that I'm going into the domain is starting doing this, and then what is the domain going to do? At some point, if the domain has changed, it's going to call the listener and say, hey, I have changed, I removed the value. So what is this going to do? That's going to go to the list of constraints that you have seen, and it's going to propagate this list of constraints in the sense that it's not propagating them itself. It's going to tell the solver, please propagate these constraints. Wow, isn't that cool? Okay, so the domain listener here, every time when you have an event like this, is going to tell the listener that I've shown you inside the implementation of the variable, and it's going to propagate the list which are inside the variable itself. Now you see a beautiful implementation, and you see this connection between the variables and the constraints. All right, good. So one more thing that I need to tell you before we are done. You see these variables, this method here, these are three methods that correspond to the very same three events that I've been talking about. But instead of propagating a constraint, what you do is you execute a function. That's going to be very useful for some very simple constraints, where you just don't want to create a constraint. You know that when something happens, you just execute that function. So you'll see that, in the next video. So I hope that you deeply appreciated the beautiful connection between the variables and the constraints, and how the constraint propagation is working in a very data-driven fashion. So stay with us to see the constraints implementation.